Yes, sir, you can start it now.
Okay. Good afternoon, everyone. This is the SCPLD class, and basically, it is a C language class, and we are going to see pointers today. Okay. So, I think you guys have the ideas about pointer earlier. You might have studied in the previous semesters about the pointers. So, let us revise that topic again, and then we'll see the 8 questions based on the pointers. Okay. So what is pointer? Pointer is basically a variable which can store the address of another variable. Okay. You can create pointer of any type. It may be of type integer or character or array or function or any other type. It may be of like integer, float, anything. Okay. Now the question is that what will be the size of pointer variable? If you create a pointer variable,
Uh, Sir,
then
sorry to
what will
interrupt
be?
you. Yes, sir.
Yeah.
Sorry to interrupt you. But voice, there's a disturbance in voice. Can you increase your voice?
Just a second.
There is a disturbance in the voice. Please increase your voice, sir.
Hello. Am I audible now? Is it okay?
Yes,
Hello.
sir. Yes. Yes, sir. Yes.
Okay, okay. So, as I was saying, today we are going to learn the topic pointer, pointer in C language, and we are going to see some of the features of the pointers and the operations which we perform on the pointers with many examples, and then we'll see the get question based on the pointers. Okay. So let us start. What is pointer? Pointer is basically a variable which can store the address of another variable. Okay. You can create any variable like integer, float, character, and if you want to store the address of that variable, you can create another variable of the similar type which can hold the address. Okay. So whenever you want to create a pointer variable, that pointer variable can be used to access the value of another variable. Okay, we can store the address of another variable, and by applying the pointer or asterisk symbol, we can access the value of another variable. So pointer is very much useful in C language or C++ language if you talk about. Okay. Now the question is that what will be the size of a pointer variable? If we create a pointer variable of type integer, what will be the size of the pointer variable? So it depends on the architecture of the system. For example, if you are using a 32-bit operating system or architecture, in that case, the size of pointer variable is a 2 byte. Okay. So now let us take an example. As you can see here, I have declared one variable which is n. It is of type integer, and we are assigning the value 10 here. Okay. So this 10 will be stored somewhere in the memory location, and that location is given a name as n. So that location is given a name as 10 as n here. Okay. But that location will also have an address. Okay. In the memory, that location will also have an address. Okay. Generally, if you talk about the memories, how memories are organized or how it is created. So the memories are created using the registers and flip-flops. Basically, if you have learned some DCFM subject, you might be knowing it. Okay. So basically, how the memory are created? Memory are basically created like a series of flip-flop or series of it is a series of flip-flop, or we can say it is a register. Okay. How the flip-flops are created? The flip-flops will be created, okay, using the multiple gates. Okay, and how the gates are created? They are created using the transistors, and how the transistors are created? They are created using the PN junction. Okay, so and PN junctions are created using the semiconductor material. Okay, So basically, using that semiconductor material, we are developing the chip, or we can say memory. Okay. So memories are generally organized in a you can say 8-bit pattern. It's a byte addressable generally. Okay. However, it can vary architecture to architecture. Okay. So if we are using 32-bit architecture, in that case, the pointer variable will occupy 2 bytes of memory. Okay. Or we can say the integer will also occupy the 2 byte of memory. Okay. If the architecture changes, in that case it may utilize 4 byte. For example, if you are using the 64-bit architecture, in that case the size may vary. So here in this example we can see integer, okay, and variable is there n, and which is having the value 10. Now we are creating one pointer variable. Okay, so if you want to create a pointer variable, you can simply write data type, then you can use asterisk symbol. Okay, and then you can write the variable name. Okay, so here p is a pointer variable, and we are trying to store the address of variable n inside the p. So how we are doing that? So we are using the operator called as address of operator here. So here you can see ampersand symbol is given on the right hand side, okay, of the assignment operator. So that ampersand symbol is nothing but address of operator, and it is responsible to find out the address of any variable. So here, using this operator, address of operator ampersand symbol, we are trying to obtain the address of variable n. Okay. Once we get the address of variable n, we are trying to assign the address into the variable p, which is of type pointer. So we know that pointer is a variable which can store the address of another variable. So here the p is storing the address of n. Okay. So in future, if you want to access the value of n using p, then we can simply print the value of p by applying the pointer or asterisk symbol. Once we apply the pointer or asterisk symbol, we will get the value of n. If we don't apply the asterisk symbol or simply print the value of p, in that case we will get the address of n. So how to declare a pointer? So generally, if you want to declare any pointer, we are using the we are writing the data type. First, we need to write the data type. Okay, then we have to we have to write the asterisk symbol, which is also called as a indirection pointer. Okay, or we simply call it as a pointer. Okay, and then we are writing the variable name. Okay, so here in this example, you can see we have created two variable. First is a, and the second is c. A is of type integer, and c is of type character. One thing we need to keep in mind that whenever we are creating an integer pointer variable, so it will hold the address of only integer variable. Okay. If we are creating a character pointer here, in that case, this pointer variable c can hold the address of any character variable. Okay. So we have to keep in mind that we have to use this similar type of pointer variable if we are trying to store the address of uh, any variable. Okay, so type should be matched here. If you want to store the address of an integer variable, so you create the pointer variable of type integer. Okay, if you want to store the address of you can say character variable, you create a pointer of type character. Okay, so to create a pointer, just we need to write the data type, then we write the asterisk symbol, and then you can use any valid variable name. Okay. Now let us take an example. So suppose we have a variable called number, which is a normal variable. Assume that it is an integer variable. Okay. So here, as in the picture, you can see we have a variable called number, which is having the value 50, and this value is stored inside the memory somewhere. Okay. And it's a normal variable. Normal variable means what? It is a plain variable. It is not a pointer variable. Okay. So here you can see, and it is storing the value 50. Now, as you can see from the picture, this memory location is having the address FFF4. That is the address of this memory location. Okay, and we have another variable which is of type pointer. It is a pointer variable. Okay, and it is of similar type as that of number. It is also an integer, but it is a pointer variable. Okay, so what it can do? It can store the address of another variable. Now it is holding the address of the variable number. As you can see from the picture, the address of a variable number is FFF4, and it is stored inside the variable P. Okay. The variable P is also having some address, that is triple A3. That is the address of P. Okay. Now P is holding the address of number. Okay. So whenever you try to print the value of P, okay, it will print FFF4. And if you want to access the value of variable number, okay, if you want to print 50 or the value of number, then you can just apply the pointer in front of P. You can apply the asterisk symbol in front of P and print it using the printf statement. So if you do so, we will get the value 50. Okay. Now let us take an example. So here you can see we have written one program, the simple C program. Okay, it is illustrating the basics of pointer, how to use a pointer. Okay, so as you can see here, we have included a file stdio.h. Okay, and then we are writing main function is there. Okay, and in front of main we have written int. Why we have written int here? Because the main function is returning a value 0. Okay, and 0 is of type integer, that's why we are writing int here. Okay, so basically the int in front of main is indicating that the return type of this function main is integer. Okay, then we have created one variable called number. So this program is based on the previous example. Okay, just we have seen now there were two variable. First is number, which is a plain variable, simple integer variable, which is holding the value 50, and p here is a pointer variable. It is of type integer. Okay. Now you can see here the statement p is equal to ampersand number semicolon. Okay, so this statement will allow the compiler to store the address of variable number into a pointer variable p. Okay. So what is happening here? We are obtaining the address of number variable using the ampersand operator, or we can say address of operator. Okay, and then we are trying to store that address in a variable p. Okay, now once we have the address stored inside the p, so we are trying to print the value of p. So in the first printf statement, I have written message address in p variable is, and then we have printed the address. Okay, then in the next statement we are writing printf, and then we have written the value of number variable is, and then we are writing here pointer p. So observe this statement very carefully. If we are writing pointer p, it means that we are trying to access the value of another variable whose address is inside the p. So basically p is holding the address of number, and if we apply pointer here, so we will get the value of number. So the value of number is 50. So in the second statement it will print the value as a 50. So you can see in the output, first time when we are running the printf statement, we are getting the address in the output, and second time we are getting the value. So that address belongs to which variable? Number variable, and that 50 value belongs to which variable? Number variable. So using p only we can access both the things. If we print the p simply, okay, without the asterisk symbol, without the pointer, in that case we are getting the address of number, because p is holding the address of number. And we, if we are applying the pointer in front of p, okay, so indirectly what we are doing, we are applying the pointer in front of address of number. Okay, because p is holding the address of number. So when we are applying the pointer in front of address of operator, in that case what will happen? It will give you the value. There is one new name given to this pointer asterisk symbol. That name is it is also called as a, we can say, it is a value at the address operator. Okay, so pointer is also called as a value at the address operator. What is the meaning of this value at the address? It means that if you give the address of any variable to the pointer, then the pointer will give you the value of that variable. Okay, so here you can see P is holding the address of number. Okay, so we have the address of a variable number, and onto that address we are applying the pointer in the second printf statement. So what is happening here? We are applying the pointer onto the address of some variable. So what the pointer will give you? It will give you the value of that variable. So P is holding the address of number, and we are applying the pointer onto that. That's where we are getting the value of number. Okay. So pointer is also called as a value at the address operator. Ampersand symbol is also called as a address of operator. Okay. So this is how the basic pointer works. Okay. Now we can also, in the previous example, you have seen how to use the pointer with integer. Similarly, you can work it with the simple data type like float, character, or any other data type. You can also apply the pointers to the array. Okay, we can also apply the pointers to the array. For example, we have an array here whose name is ARR, and it is having the size 10. It means that the index of the array will start from 0 and it will go up to size minus 1, that is 10 minus 1, 9. Okay, the array is of type integer, so we have created one pointer array here which will hold the address, of array. Okay, which will hold the address of array. So what we are doing here in the pointer array, we are assigning the uh, address of array. Okay, we are assigning the address of array because pointer array is going to store the address. Okay, similarly we can also use pointers to a function. We can also apply pointers to a function. For example, we have a function called a show. Okay, and it is declared, it is having only one parameter of type integer. And if you want to create a pointer to this function, we can simply assign the address of this function to any pointer variable. So in this example, you can see here we have created one pointer variable which is called as a p, and then we have assigned the address, okay, address of this function show inside the p variable. So now p is pointing to the address of the function. Okay, p is pointing to the address of the function. So if you want to call any function, you can simply use the pointer. Okay. Next is a pointer to the structure. How can we apply a pointer to the structure? So first we need to know that how to create a structure. In order to create a structure, we are using the keyword struct. Then we are giving the tag name, structure tag name, which is st here in this example. And then we are writing integer I and float f. We have two members in the structure here. And then we are writing the structure variable name ref. Okay, so ref is what here? Ref is a structure variable name. Okay, now I want to create a pointer to this structure variable. So what I will do, I will write struct st. Why we are writing struct st? Because the pointer variable which we are trying to create here is for this particular structure. So the type will be also belonging to this structure only. Okay, it means that whenever we create a pointer variable for any particular data type, then the type of that pointer variable will also be the same. Okay, so here the ref, we are trying to store the address of ref in a pointer variable p. Okay, so this p pointer variable will also be of type which is similar to ref. So ref is of type struct st. So p is also of type struct st. So basically, what I'm trying to say here is that the pointer variable will always have the type which will match with the variable whose address it is going to store. Okay. So in this statement, you can see here we have created one pointer variable p, okay, which is of type struct st, because the variable whose address we are trying to assign in p is of type struct st. Okay, so we are storing the address here. Okay, in future, if you want to access the elements of the structure, okay, using ref, you can use the dot operator. But if you want to access the element of the structure using pointer variable p, in that case we will use the arrow operator. Okay, so basically two operators are used to access the elements inside the structure. First is the dot operator, and second is a arrow operator. So if you want to access the member of the structure using the simple structure variable, we will use the dot operator. If you want to access the element of the structure or member of the structure using the pointer variable, structure pointer variable, in that case we will use the arrow operator. Okay, so this is how the pointers uh, can be applied to the structure. Okay, another example may be like we can also apply the structure inside the members of the we can also apply the pointer to the members of the structure. For example, the variable I is there, the variable f is there. So we can also make those variables I and f as a pointer variable. So that is also possible. So with a structure and pointer, we have two varieties. First is structure using pointer, and second is pointer within the structure. Second is pointer within the structure. So the first example we have seen here, that how to use pointer with structure, and second example we can see that how to use pointer inside the members of the structures. That is also possible. Okay. Now let us see what are the advantage of using a pointer. What are the advantage of using a pointer? So basically, the pointer will help to reduce the code, and it will improve the performance of the programming, and it is used basically in all the data structure. If you talk about the stack, queues, or basically if you talk about the trees, linked list, queues, everywhere it is used. Without the pointer, dynamic memory allocation is not possible. I mean, possible, it is possible, but pointer is very much efficient. If you talk about the memory allocation, especially dynamic memory allocation. Okay, so dynamic memory allocation is always used in case of if you want to create a tree, if you want to create you can say linked list, if you want to create a single linked list, doubly linked list, okay, circular linked list, and doubly singly circular linked list, doubly circular linked list, okay, or if you want to create a queue, okay, circular queue, doubly circular queue, okay. So everywhere the pointers will be used, because the concept which we study in the data structure uh, is heavily dependent on the dynamic memory allocation, and the dynamic memory allocation uses the pointers. Okay. So pointers help us to manipulate the data easily, and it also improves the performance because it directly interact with the memory location. It directly interact with the memory location. Okay. Earlier, it was not possible to return one or more than one values from a function, but using pointer, we can return more than one values using the from the function. So how we are going, how we are achieving that? So it is very simple. Pointer basically when we use the pointer in the function, so it access the element with the help of address of the element. Okay, so we don't pass the copy of argument, or we can say we don't pass the copy of data or copy of a variable, local variable, as a function argument. Okay, we don't pass the copy of data, or we can say copy of a variable as a function argument. In place of that, we pass the address of the variable as a function argument. Okay, And inside the function parameters, we receive the values, the addresses or the references. Okay. Once we receive the addresses or references, then we can directly access the element from the memory location, even though we are in the separate function. We are away from the main function. The control of the program is away from the main function. Still, we will be able to access those memory location because we have the address. Once we have the address, we can access the memory location from anywhere in the program. Okay. So using that, we will be able to manipulate the original variables which are there in the main function from any sub function. Okay. For example, we are having a function called as a, you can say, sum of two number. There is a function called sum, and we are passing the address of two variables. Okay, whose numbers to be added. Okay, from the main function. So as we have the addresses, okay, so we can directly do the sum and reflect the result into the third variable. Okay, we can also pass the address of third variable. Okay, and we can manipulate that inside the function. So in this way, we can access the variables inside the function even though we are out of the main function through the pointers. Okay, so pointer make it very much easy to access any element from anywhere, and that's why we are able to manipulate more than one variable which are there in the main function from this sub function, and hence we are able to return more than one values. Okay, we have already covered that. We know that it is easy to access the memory location using the pointers because we have the address. Now, what are the major uses of the pointers? So, pointers are heavily used in the dynamic memory allocation. So, what do we mean by dynamic memory allocation? Dynamic memory allocation means what? Creating a memory during the execution of the program or allocating the memory during the execution of the program. So, basically, we are using the four functions which are there in the dynamic memory allocation. First is a malloc, second is a calloc, then third is a realloc, and fourth is a free. So we are having four functions there in the dynamic memory allocation. Malloc function is used to allocate the memory. Calloc function is also used to allocate the memory, but it has two parameters. Uh, it has different parameters as compared to malloc. And then we have calloc function, which is used. Then we have reloc function. Reloc function is used to reallocate the memory. Suppose we have already allocated some memory, and if you want to increase the size of the memory, then we can use the reallocate function to reallocate, reconsider the memory size. Okay, and then the last function is free function, which is used to deallocate the memory or free the memory. Okay, deallocate the memory or free the memory. So these four functions are used in the dynamic memory allocation, and all these four functions are heavily dependent on pointer because some of the functions return the address once the memory is allocated, and if you want to capture the address, you must have the pointer variable. Okay, so the whole dynamic memory allocation is all around the pointers. Then if you are working with the arrays, functions, and the structure, it is very easy to pass the array as a function argument if we are using the pointers. Okay, and also you can call the functions or use the functions using the pointers. You can also create the pointers for the functions and for the structures. We have seen just now that we can create the pointer variable for the structure also, and we can also create the pointer variable for the member of the structures also. So these are the major areas of pointers. Okay, and the whole programming is dependent on this pointer. Okay, now let us see what are the operators we can use onto the pointers. So basically we know that pointer is an address and it's a numeric data, so we can apply the operators like the plus plus, minus plus, and then plus and minus. So in other words, we can say that we can apply the increment operator, the decrement operator, the addition, and then subtraction, and also we can apply some comparison operators, like we can compare the values. Okay, we can compare the values. Okay, let us assume that PTR is one of the integer, okay, and it is a pointer which is pointing to the address 1000. So initially PTR is a variable uh, which is an integer, it is a pointer variable which is holding the address 1000, and assume that we are working with the 32-bit architecture. Okay, so when we perform the PTR plus plus operation, okay, when we apply the increment operator on PTR, then what will happen? So as we know that initial address was 1000, so PTR was initially holding the 1000, and PTR is of type integer. So when we write PTR plus plus, then what will happen? Okay, then what will happen? It will go to the next memory location. It will go to the next memory location. It means that it will point to the next memory location. Okay, next integer memory location. So basically, so PTR was initially holding 1000. Okay, and one integer variable requires 4 byte of memory in the 32-bit operating system. Okay, so here what will happen if we write like PTR plus plus, then we are incrementing the value of PTR. So when we are writing PTR plus plus, then it will not increase the value 1000 by 1. It will increase the value 1000 by 4 here, because PTR is of type integer, and it count 4 byte. It takes 4 byte for one integer data. It takes 4 byte for one integer data. So when we increment the pointer, it will automatically jump to the next possible location of the integer variable. Okay, so the next possible location can be after 1004. Okay, so it will shift by 4 byte of memory. It will shift by 4 byte of memory, and it will jump to the next location, fourth location. Okay, so why it is happening? Because we are working with the integer pointer. Now suppose that pointer is of type character, and then if we apply the plus plus operator, then what will happen? So in that case, the PTR will jump by only one location, and the next location it will be 1001, because the if PTR is of type character, so it is going to consume only 1 byte of memory. It is going to consume only 1 byte of memory, and in that case, it will jump by only one memory location. Okay. Similarly, we can perform the other operations like the subtraction or decrement operator, or the comparison. So let us take an example that how to perform increment operation using the pointer. So here is an example. So the first line is hash include stdio.h. So basically, this line is basically used to include borrow the library into our program. That library is stdio.h, standard input output header file, and we are trying to access that header file in our program. Okay, that's why we have written this first line. The second line is declaring a constant variable, constant, which is of whose name is max, and it is holding the value 3. The value will not be changed throughout the execution of program because it's a constant. Now after that, we are having a main function. Inside the main functions, we have created one variable, sorry, one array. Okay, and the name of the array is var. It is holding 3 elements, and we have directly initialized the array using the parenthesis. Okay, and given the elements separated by comma. So as you can see here, we are having three different values. The first value is 10, second value is 100, and the third value is 200. Now if you talk about, if you imagine about the memory location, how the memory is allocated to this particular array. So there you can see that the first element 10, that will be stored in the location whereof 0, where 0 is the index of the array, index of the first element of the array. The 1 will be the index of the second element of the array, and the 2 will be index of the third element of the array. So the value 10 is stored at var of 0, value 100 is stored at var of 1, and the value 200 is stored at var of 2. Okay. Now we are creating two different variable. One is I and second is a pointer variable ptr. Okay. So we are going to show that in this program we are going to show how to increment the pointer. Okay. So now what we are doing, we are assigning the address of the array to the ptr. We are assigning the address of the array to the ptr. So as we know that the array name itself contains the base address of the array. So if we say that what is the base address of this var array, then the base address is contained with the name var itself. Okay. So when we are writing ptr is equal to var, then what will happen? The address of the array var, the base address of the array var will be copied inside the ptr. Okay. Now let us remind the concept of variable array here. Just remind the concept of array here. Okay. So what is the meaning of base address of an array? What is the meaning of base address of an array? Okay. So base address of an array is nothing but one, the address of the first element of the array. Okay. So here the address of var of 0 is nothing but the base address of the array. Okay. So now ptr is holding the address of the first element of the array. Okay, address of the first element of the array, address of var of 0. Okay. Now you can see we have applied one loop. For loop is there, and the loop has been initialized at 0, and it will go up to max minus 1, because the condition is like I should be less than max. Okay, and then we have written I plus plus to increase the value. Okay, so here we are applying the plus plus with the variable I, which is a plain variable, not a pointer variable. Now we are printing the address, okay, address which are stored inside ptr, and then we are printing the values which the ptr will point to. Okay. So when I equal to 0, then we are printing the value of I, which is 0. So in the message you can see address of var of 0 is there, then equal to, we are printing the address. So we're just printing the ptr. So when we print the ptr, so we will print the base address of the array. So here the base address of the array is b30. I'm reading only last three digit. Okay, b30. Now we are printing the value. So if you want to print the value, we have to simply apply the pointer. So in front of ptr, we are applying the pointer. So when we apply the pointer, we are getting the first element 10 in the output, as you can see in the output. Now we are incrementing the pointer. We are writing ptr plus plus. So here basically our array is of type integer, so it will jump by 4 location. Okay, ptr will jump by 4 location, and it will point to the next integer variable. It will point to the next integer variable. Okay, so the next integer data which are there in the array is 100, and it focuses on var of 1. Okay, so the I plus plus will execute, and then loop will increment, and again it will make the comparison. Now the I is 1. Okay, so 1 is less than max, condition is true, and then again it will print the index address of var of 1 is equal to, then it will print the address. So as you can see here in the output, we are getting b34 as a next address. So here you can see from the previous address we have the difference of 4 here. We have the difference of 4 here. In the first execution the address was b30, in the second execution the address is b34. It means that the address has been changed by 4 location. Okay, because it's a integer pointer variable. Okay, so whenever we are doing the plus plus operation, increment operation, it will go to the next location. Okay, next location. Okay, and next location will be after the 4 byte of memory. Okay, now we are printing, after that we are printing the value. Okay, value which is stored at the B34. So value stored at B34 is 100. So that is there in the output. Then again PTR plus plus is performed. Then PTR will again increment by 4. So next time you see in the output is B38, and the next value is 200, which will be printed because again condition is true. Okay, so this is how we are incrementing the pointers. Now let us see how to decrement the pointer. So a similar example we have taken here. Okay, so first line again is hash include str dot h, inclusion of the header file, standard input output. Then we have a integer constant max equal to 3, initial value is 3, that will be fixed throughout the execution of the program. Okay, and then var is there, var is array is there, which is holding 3 values, 10, 100 and 200. Okay, then we are again having two variable. One is a simple variable, integer variable I, and then we are having the pointer variable ptr. Okay, now as you can see here, we have to decrement. We have to perform the decrement operation. So the ptr is initialized at the address of the last element of the array. So how we can get the address of the last element? So we can simply write address of var max minus 1. So max is 3. So max minus 1 is 2. Okay, and so we are writing address of var of 2. It means that the last element of the array. So we are storing the address of last element of the array into the ptr. Okay, into the ptr. So once we have the address of the last element, then we can perform the decrement operation, because we know that when we perform the decrement operation, the address will decrement by 4. So we have to set the address up to the maximum value. Okay, now we are writing I equal to max, and then I should be greater than 0, and I minus minus we are performing here. We are reversing the loop, and then again we are printing the value here. So here we are printing ptr and again the value. So when we print the ptr, it will print the address. So initially I equal to set to the max I equal to 3. Okay, condition will check 3 is greater than 0, condition is true, and then we will print the address of var of, and then here we are writing I minus 1 because I is initialized to 3 initially. So I minus 1 is 2. So address of var of 2, and then we are printing the address. So we are getting in the output BCD8. We are getting in the output address as a BCD8. I am reading the last 4 digit of the address. Once we have that, then we are printing the value which is stored there. So we are printing the value by applying simply the pointer onto the variable ptr, because ptr is holding the address, and if we apply the pointer, then we can access the value. Okay, so we are able to print the value 200. Okay, then we are performing the ptr minus minus operation, which is decrementing the ptr. So it will decrement the ptr by 4, because again here ptr is of type integer and the array is also of type integer. So when we perform the decrement operation, it will jump by 4 memory location. Okay, so next time when we print the address, we will see that there is a difference of 4. So after performing the ptr minus minus, the address has been changed. Then I minus minus will be executed, and then again condition will be checked. Now I is 2, 2 is greater than 0, condition is true. Then we are printing the ptr address. As you can see in the output, this time the address is BCD4. So initially it was BCD8, now it is BCD4. Okay, the address has been changed by 4. Then we are printing the value. The value stored there is 100, which is there in the output. And then again we are performing the ptr minus minus. This is how it will print the next value. So next time we can see in the output BCD 0 is there and the value 10 will be printed. Okay. So till now we have experienced that if we are using the integer, it is jumping by 4 location. If we are incrementing, it will go to the it will jump by 4 location upward. If you are using the decrement operation, then it will go downwards by 4 location. Okay. So it depends on the type of pointer which we are using or type of variable which we are using. If it is an integer, it may jump by 4 byte. If it's a character, it will jump by 1 byte. Okay, so it depends. So these are basic two operations which we perform on the pointer. That is the incrementing the pointer and decrementing the pointer. And these are heavily used in the you can say linked list and the you can say trees. These are heavily used. Okay. Now, from that example, we are able to understand that how the pointer behaves. So from that example, we have known that if we increase the value of any pointer, so it will depend on the data type, and if it is an integer, it will jump by 4 byte. If it's a character, it will jump by 1 byte. Okay, so it also somehow depends on the operating system. For example, if we are using the 32-bit operating system, then in that case, and if we are creating integer pointer, in that case, it will differ by 2 bytes only. If we are using the 64-bit operating system, in that case, it will differ by 4-bit. So normally we consider that we are using the 64-bit. Okay. So how to find the next address when we are jumping from one location to another location using the increment operator or decrement operator? Then how to find the next address? Okay. So for that we can perform the simple addition operation. So and the formula is given here: new address is equal to current address plus number into size of data type. Number into size of data type. Okay. So number indicate that how many locations you want to jump, okay, or how many numbers you want to add into the current address. For example, if you're writing new address is equal to current address plus 1 and the data type is integer, so what will happen? So it will if the current address is 1 and data type is integer and the number is like 2, then what will happen? So what we are having, new address is equal to current address. For example, take 1 and number we are adding is 2. So and data type is integer here. So what will happen? 2 into 4, that is 8, and that will be added to the current address 1, and the resultant address will get is a 9 in the output. Okay. So basically, if you want to find the new address or the address of the new memory location, then you have to look at the initial address which are there, the current address, then we have to see the number which we are trying to add into the address. Okay, which we are trying to add into the address. Okay, and then we have to multiply it with the data type size. If it is integer, multiply it for by 4 byte for 64-bit operating system, multiply it by 2 byte for 32-bit operating system, and if character, multiply it by 1. Okay, because the size matters or data depends on the data type. Okay. Now we are going to perform this operation, the addition operation. Okay. So in this program, you can see that we have a variable called as number. So initial value is 50, and p is a pointer variable. Okay, and we are trying to perform the addition operation in this program. We are trying to add some value to the address. So what will happen after addition? So you can see here we have written p equal to address of number. It means that we are trying to assign the address of variable number into pointer variable p. So now p is holding the address of number. Then we are printing the address. Okay. So in the output you can see the address is like 4300 is there. Okay. Then we are performing the addition operation. P equal to p plus 3. So initially the address was like 4300 and we are performing P plus 3. So how much it will add? It will add 3? No, it will not add 3. It will add 3 into data type size. It will add 3 into data type size. So and data type here is integer, and we have assumed that integer will take 4 byte. So 3 into 4, 12 will be added into P, and that 12 will be reflected in the output. So as you can see here in the output, after adding 3, when we are when we are printing the address, so there you can see that we are getting 312. Okay, initially it was 4300, now it is 4312. So it is incremented by 12. So uh, very simple calculation is there. So number here we are adding is 3. So that is not the actual figure which will be added internally. So what will be added internally? 3 into data type size. Okay, and P is the initial address. So the new address will be is equal to the initial address plus the number which we are adding into data type size. So here we have assumed that the data type size for integer is 4 byte. Okay, so P equal to P plus 3 into 4. So P was initially 4300. So 4300 plus 3 into 4, that is 12. 12 will be added in the initial address and you will get the final address. So you can see in the output. So there is a difference of 12. And the logic is also given. 12 is added because size of integer is 4, which is multiplied by 3, and it will give you 12. Okay. So this is how we perform the addition. Now we are going to see the next operation, which is the subtraction operation. Okay, so this is the example. So this example is also similar to the previous example. As you can see here, again we have written hash include stdio.h, that is the inclusion of the header file. Then we have a main function, and after that we have a variable declaration, and that variable is created number equal to 50. 50 value has been assigned to the variable number. Now we have created one pointer variable p, which is going to hold the address of number. That's why we have written p equal to ampersand number. It will store the address of variable number into variable p. Now p is holding that particular address of number. Now we are printing that address. So initially the address is 4300, and then we are performing the subtraction operation. So when we perform the subtraction operation, p equal to p minus 3, then what we will get in output is 3 in, it will subtract the value, not 3, it will subtract 3 into data type size. So what is the size of data type here? Again 4 byte, because it's an integer number. Okay, so 3 into 4, it will subtract 12 from the value of p. So initially the value of p was 4300, 12 will be subtracted, so we'll get 4288 in the output. Okay. So after subtraction, when we printed the value, the address, we are getting 4288 in the output. Again, the similar logic is used. The new address after subtraction is equal to the initial address minus the number which is to be subtracted into the size of data type. Okay, so here the size is 4 byte because and the data is of type integer, and we have assumed that we are working with the 64-bit operating system, and it is occupying 4 byte of memory for storing a single integer data. Okay, so this is how we can perform the subtraction operation. So till now, what we have covered, we have seen the introduction to the pointer, we have seen the um, on what we can apply the pointers. We can apply the pointers on simple variable, arrays, functions, structures within the structure, and then we have seen what are the operations which can perform on the pointers. So we have seen in the increment operation, Then we have seen the decrement operation. We have also seen the concept of pointer with the memory, with the data type, okay, how it differed with the data type, okay, and then we have seen the another operation like addition and subtraction onto the pointers. Okay, one last operation is there which is also called as the comparison of the pointers. So that also we will see. Okay, so let us see that. Okay, so just like the we can say just like the uh, simple addition, simple subtraction, or increment or decrement, we can also perform the comparison operation. So basically, the comparison operation include the operations such as the equal to, less than, greater than. These operations can be applied onto the pointers. Okay. So while performing the comparison, we have to uh, we can apply any one of the operations like equal to and less than and greater than. So let us see an example based on the pointer comparison, how we can apply the comparison operator on the pointers. Okay. So here you can see that we have written hash include stdio.h. That is again we are including the header file standard input output. Okay. Then we are writing const space int space max equal to 3, which will declare an integer constant which is having the value 3 as a final value, and it will not change during the execution of program. Then we have written int main. Okay, so main function is returning the integer value, then opening curly braces, and inside that we have created one array which is holding three values. The first value is 10, second value is 100, third value is 200. Okay, then we have a simple integer variable I, then we have a pointer variable ptr. Okay, after that we are assigning the base address of the array in ptr. Okay, and we have given the value of I, initial value of I as a 0. Then we are writing a while loop, and we have given a condition while ptr is less than equal to address of var max minus 1. So we have to continue the loop until we reach to the address of the last element. Address of the last element. So here you can see that inside the while condition we are comparing the two pointers. First is pointer is ptr, which is holding the address, base address of the array, okay, which is b20, and the second address in comparison is the address of the last element of the array, which is b28. So we have to run the loop until the both addresses are sorry, until the ptr is having the value less than or equal to where address of where max minus 1. Okay, until the address of the last element. Okay, now we have the two printf statement inside the while loop. The first printf statement, the address of where, okay, We have written address of var, then percent d, and we are printing the value of I and then PTR. Basically, we are printing the address here, okay, and then we are printing the corresponding value which are stored at that address. Okay. So first time the condition will be checked. PTR is holding the base address which is B20 and the address of last element is B28. Okay. So B20 is less than equal to B28. Yes, correct. Condition is true. Okay, and it will execute both the printf statement and it will print in the base address which is B20 and it will print the value stored at the base element, that is the first element of array 10 will be printed in the output. After that we are incrementing the pointer ptr. So we are going to go to the next location, so we are writing ptr plus plus, and also we are writing I plus plus because we have to print the next index value. So next time ptr will jump by 4 location because we are applying the increment operation. So and ptr is of type integer, so it will jump by 4 location. So next address is b24, and again condition is checked in the while loop. ptr is less than equal to address of var max minus 1. So here we are checking b24 is less than or equal to b28. Condition is true, and it will print the both the printf statement. Okay, and it will print the address of the next element which is b24, and the value stored at that element is 100, which will be printed in the output. After that we are going to the next location by again using the increment operation, and the next location is b28. So now ptr is pointing to b28. ptr is holding the value b28 and I plus plus is executed, so I will also go to the next location. So now I becomes 2. Initially it was 0, then it became 1, then it became 2. Now again comparison will be done. P28 is less than equal to B28. Condition is true because it is equal at least. Not less, but it is equal. Okay, so condition is true. So again the address will be printed which is B28, and the value of the last element will be printed which is 200. Again PTR will be incremented and it will go to the next location B32, and here B32 is less than equal to B28. Condition is false because it is not less, neither it is less nor it is equal. So both the conditions are false, so the overall condition will be false and the loop will be terminated. So this is how we are able to print the address of each location of the array along with its corresponding values, along with the corresponding data stored inside the memory. Okay, so this is how we can use the comparison operator. Basic these comparison operators are heavily used in case of if you say like linked list or point. If you are working with the linked list and you want to create a new list, or you want to widget the linked list, okay, you want to widget the queue, circular queue, okay, or single linked list, double linked list. So basically, for traversal of the linked list, we are heavily using the comparison operators along with the pointers. Okay. Now let us see function, how to use a function with pointer. Okay, how to use a function with pointer. It means that how to use a function pointer, how to use a function pointer, or how we can say how to create a pointer for a function, for a particular function. Just like for integer variables we are creating the pointers, similarly we can also create the pointers for the functions. Okay, so in this program, as you can see, we have written hash include stdio.h. Then we have declared one function addition. It is returning a data, integer data. That's why the return type of the function in the declaration is integer. Then we have main function. Okay, inside the main function, return 0 is missing. That you can consider should be there. Okay. Then we have one variable called result inside the main, and then we are creating one pointer variable ptr, which is created to point to a particular function. So whenever you are creating a pointer variable for a function, then you have to put an extra bracket in front of the pointer variable and after that also. So as you can see in the red line, the first red line, we have created one pointer variable for the function. Now the name of function is addition. So we are finding the address of that function by using the ampersand operator, by using the address of operator. We are taking the address of the function addition, and we are storing that address into the variable ptr. Okay. After that, we are calling the function ptr with the help of pointer variable. So whenever you want to call the function using the pointer variable, you have to just write the pointer variable using the both bracket with the pointer variable, and after that also. So we are calling the function ptr. Here the flow of the main program will jump from this location to the function. So it will go to the function which is given below the main function. Okay. Here, uh, when the program will control will come here, then it will create two variable a and b of type integer, and then it will print the message enter two numbers question mark. Then after that, the user will enter some number. As you can see in the output screen, it will enter 10 space 15. As soon as we hit enter, the two data 10 and 15 will be read by scanf function, and it is stored with the in the variable a and b respectively. So now a is holding 10, b is holding 15. Okay, and we are returning a plus b. So first the a plus b calculation will be done. So a is having 10, b is having 15. A plus b, that is equal to 10 plus 15 equal to 25, and then return statement will execute, and it will return the value 25 to the calling part. So the function and the place from where the function call was invoked, there the 25 value will be returned, and 25 will appear there logically, and it will store into the variable result because of that assignment operator. Okay. Now the variable result is holding the value 25. Okay. So when we print the particular variable, and then what will happen, it will print the result. So it will print the sum is 25. Okay, because result is holding the value 25, and we are printing the result inside the main function. Okay, so this is how we can use the function. We can apply a pointer to a function. We can apply a pointer to a function. Okay, the next topic is array of pointers. I hope everyone is aware of array, how the array is created and how it is there in the memory. Okay. So just like array. So what array will do basically, array can store some data in the sequential manner. Okay. And the consecutive memory location. It has contiguous memory location. Okay. So when we create array of size 5, and then what will happen? The 5 consecutive memory location will be allocated, and we can store data in that particular memory location. Okay, we can store 5 different data. If we create an array of type integer, we can store integer data. If we create the array of type float, we can store the float data. If we create the array of type character, we can store the character data. Now, here we can see that we can also create the array of pointers. Suppose we want to store the, we don't want to store the simple data, but we want to store the addresses. We have a huge number of addresses, like suppose we have the 1000 addresses, and we want to store that addresses into memory because those addresses are references for some important data. Okay. So in that case, creating a simple single pointer variable will not be enough. So we can simply create the array of pointers. We can create the array of pointers because we know that we have to store more than one addresses. Okay. Suppose we want to create the pointer, or we can say the array of pointers. We want to create the array of pointers for storing the addresses of integer variables. So in that case, we can create a integer array which is of type pointer. So here we can see in the example we have written int, then space, then asterisk symbol is there, then ptr is the name of array, and max indicate the size of the array. Okay. So here what will happen if the value of max is suppose 5, then every location of this ptr array will hold the address of some variable. Okay. So let us see an example. Let us see an example based on this concept, the array of pointers. Okay. So I have again taken a simple example. So you can see here we have included the header file stdio.h. Then we have a constant max, the integer constant having the value as 3, and then we have a main function. Inside the main function we have three elements. First is 10, second is 100, third is 200, and inside that we have the array of pointers. Okay, so you can see here we have one simple variable I, then we have a array of pointers ptr. Okay, now uh, we have applied one for loop which is starting from 0 and it will go up to max minus 1, that is the size up to the size of array. Okay, up to the last element of the array. Okay, then we have written I plus plus just to keep changing the location of the array. Then we are writing ptr of I is equal to address of where of I, address of where of I. Okay, so what we are going to do here, we are copying the address of each location of the array where into the ptr array, into the corresponding location of ptr array. So now ptr is, after the execution of this loop, what will happen? The ptr will hold the PTR will hold the address of each element of var. So PTR of 0 will hold the address of first element of the var. PTR of 1 will hold the address of second element of the var, and the PTR of 2 will hold the address of third element of the var. Now PTR is enough capable enough to access the element of var by simply applying the asterisk symbol or pointers on itself. Okay, so in the next for loop, you can see here we are writing a value of var, then we are printing the index, and then we are printing the data. Okay, which are present inside the var. So indirectly, what we are doing, we are accessing the elements of var through the we are accessing the elements of var through the uh, pointer variable, through the pointer array. Okay, PTR. Okay, so using PTR, we are able to print the values stored in the var array. So using a pointer array, we are printing the values stored inside a simple array, integer array. Okay, so you can see in the output value of var of 0 is 10, value of var of 1 is 100, value of var of 2 is 200. Now let us take an example, pointer to structure. How to use a pointers to the structure. Okay, so first of all, we need to know how to create a structure. Okay, how the structures are different from the we can say union. How the structures are different from the union. Okay, so let us revise some basic concept of structure. So whenever we want to store the data in a group manner inside the memory, then we use the structure. The normal definition of a structure is it's a collection of dissimilar data type. It's a collection of dissimilar data type. Okay. Now, suppose you want to create a structure like here we have created a dog structure is there. Okay. And we are storing the four element inside the structure. The first element is name. The second element is breed. The third element is age, and the fourth element is color. Okay, the fourth element is color. Okay, so here name is a character array, it's a string, then breed is also a string, and color is also a string, and age is of type integer. Okay, so if you want to create any structure, we use the keyword struct, then we assign the tag name. Here the tag name is dog. Okay, and at the end of the structure we provide the semicolon. So as you can see that at the closing we are having the semicolon. Now inside the main function, come inside the main function. Once the structure is defined, we can create the variables for that structure. So when we define the structure, we are basically designing the memory, how the memory will look like, how many elements will be there in the inside the memory, and they will be stored together. Okay, because it's a structure. So inside the main, you can see that we have created one structure variable whose name is my dog, my underscore dog, and it belongs to dog structure. Okay, so we are providing here the four data. First is a name, which is tyke. Second is a breed, bulldog, and the age is 5, and the color is white. Okay, now after that we are creating a pointer to the structure. We are creating a pointer variable which will point to this my dog structure variable. So we are writing struct dog, which is data type for this pointer. Then we are writing asterisk symbol, which is necessary for pointer variable creation, and then we are giving a name ptr underscore dog. So this ptr underscore dog is a pointer variable which is created in order to point to the my dog, and that's where we are assigning the address of my dog inside ptr dog. So the next line inside the main, the third line you can see here, ptr underscore dog is equal to address of my underscore dog. Okay, so my underscore dog is a simple structure variable whose address we are assigning into ptr underscore dog. Okay, so now ptr underscore dog can access the element of my dog. Okay, as we know that ptr underscore dog is a pointer variable, and that's why if you want to access the member of the structure, for example, if you want to access the name, breed, age, or color using the pointer variable ptr underscore dog, then we cannot use dot operator, then we have to use the arrow operator because it's a pointer. Okay, but if you want to access the element using the simple structure variable my dog, my underscore dog, in that case we can use the dot operator. But here we are going to demonstrate that how to access the element of the structure or member of the structure using the pointer variable, using the pointer to the structure. Okay, so here pointer variable is ptr underscore dog. So in the first printf statement, we are printing the name, dog's name, and we are writing ptr underscore dog arrow name. Okay, because we want to access the member name. So in order to access the member using the pointer, we have to use the arrow operator. The second member is breed. So we are printing ptr underscore dog arrow breed. Okay. The third element is uh, age. So we are writing ptr underscore dog arrow age. Then fourth element is color. We are doing that also. Okay. So once we print all this data, you can see in the output, we have dog's name, tyke, dog's breed, bulldog, dog's age is 5, and dog's color is white. Okay. After that, we are performing some operations. We are changing the name of dog. Okay. So earlier it was a tyke, and we want to change the name of dog from tyke to Jack. So we are using the copy string function, which is strcpy, to copy the new name inside a member name. Okay, inside a member name. So earlier the name was type, and we are assigning the new value Jack. So for that we are using the copy string function strcpy. The first parameter is the destination, okay, or the variable where we want to store the value, and the second parameter is the value which we want to store in the variable. So we are writing ptr underscore dog arrow name. Okay, so we are accessing the name member using the pointer. That's why we are using the arrow operator here. Okay, and then we are giving the second parameter Jack as an input. Okay, so this Jack will be copied into the member name. Then we are changing the age. We are increasing the age. So we are writing ptr underscore dog arrow age plus plus. So age will be incremented by 1, and then we are printing the name and age after changing the information. So now the name will be like Jack, and the age will be 6. So in the output you can see the new name is Jack and the age is 6. So this is how we can use points onto the structure. We can use the pointers onto the structure. Okay, I hope everyone is clear. Now there is a question for you. Now we are going to see the gate questions. Okay. So I request you all to actively participate. Okay. So I will be giving the question to you. The question will be shown to you, and you will be having four options, and then you have to solve that option. Once you get the answer, okay, you can tell me the answer, okay, and then we will see the solutions also. Okay. So here is the first question. All of you try to solve this question and tell me the answer. I'll give I'll give you 5 minutes to solve each question. So try to solve it. Okay. I request you, if you get the answer, you tell me with the audio because I'm not able to see the chat. Okay. So if you know the answer, if you have got the answer, you can tell me with audio that this is the right option.
Or D, D.
The option is right option. Okay. Any other person who is getting the same answer?
Side D.
B. Okay. One thing we have to understand here that B cannot be the answer because okay, first you solve it, then I will show you the correct solution, and I will also give you the justification. I will give 2 more minutes on this question, and then we'll move to the next question. Any other person, any other answer for this question? The first answer I got is D, and the second answer I got it B from your side. Okay. We have to choose the option such that we will not get a type checking error. So that is our motto. We should not get a type checking error. Okay, there should not be type incompatibility. Okay, so if you focus on the first option, okay, in there we are having two parameters, okay, s and then pointer of s. So as you can see there, there's no pointer variable by the name s in our program. So first option is dismissed. Okay, first cannot be the option. Then we have three options B, C, D. From that you can choose the correct option.
सर एक्चुअली हम दो ही लोग हैं.
Okay, so we should proceed.
हाँ
Okay,
सर.
so let us discuss the solution of this question. So the correct answer is D. ओके, अब क्यों वो सही है उसके बारे में हम लोग बात करेंगे. ठीक है, तो पहला ऑप्शन जो है वहाँ पे मैंने कमेंट में लिखा है, अगर आप देखेंगे तो s is not a pointer variable. Okay, so as you can see the first option was given like s comma pointer of s. So here clearly s is not a pointer variable but simple variable, so this cannot be the answer. Second option is like I equal to, and then we are calling the function f. So here you can clearly see that I, okay, it is of type integer and s is of type short. Okay, and the function prototype you can see here is int and then short, right? So both are matching. Till now everything is fine. Okay, but when we write I equal to f of is, it means that we are trying to assign some value to the variable I. Okay, we are trying to assign some value to the variable I, but this function is not returning anything because from the function syntax, from the function signature, you can see that the return type of the function is void, right? So it is not returning anything. So if you assign a void value to the variable I, then you may get the type checking error because void is what, not defined, and I is of type integer, so there may be the compatibility issue. Okay, so the second option is also dismissed because of this. The third option is like, again we have the s as a pointer variable which is not a valid. Okay, s is not a pointer variable, and the last option is I and then pointer of p. So pointer of p is a pointer variable and p is of type short, that's correct, and I is simple integer variable, so it is absolutely correct. Okay, so fourth is the correct answer. Okay, shall we move to the next question?
Yes
You
sir.
can do, okay, you can do the audio reply. Okay, because I am not able to see the screen chat box. So let us go to the next question. This is the next question, try to solve it. I'll give you 5 minutes for every question. Take your time, analyze every option, then you can come to the conclusion.
Maybe it's A.
Why do you think like that?
क्योंकि सर पॉइंटर को स्कैनफ शायद नहीं लगता है।
नहीं बेटा, आपको ध्यान होगा, अगर अगर आपने अच्छे से स्कैनर यूज़ किया होगा तो आपको मालूम होगा कि स्कैनर में हम लोग जब भी कोई वेरिएबल का नाम लिखते हैं तो हम लोग एम्परसेंड ऑपरेटर लगाते हैं, बराबर?
ओ हाँ।
लगाते हैं कि नहीं? तो
यस
एम्परसेंड क्या करता है? वो एड्रेस देता है आपको। गेटिंग माय पॉइंट?
यस यस।
तो एम्परसेंड हमेशा एड्रेस देता है, इसका मतलब ये होता है कि स्कैनफ को हमेशा एज अ पैरामीटर एड्रेस ही चाहिए होता है ना? और पीआई में ऑलरेडी एड्रेस ही है ना, बिकॉज पीआई इज अ पॉइंटर वेरिएबल,
ओके ओके।
है ना? तो वो गलत नहीं हो सकता है, वो सही है। समझ गए ना आप मैं क्या बोल रहा हूँ?
हाँ सर।
हाँ। तो अभी आप दूसरे ऑप्शन की तरफ ध्यान दो, आराम से टाइम लो, बिकॉज कोई घाई नहीं है इस पे। scanf is always taking address as a parameter because we are always writing ampersand along with the variable name. Okay, so that pi is holding the address, so it is correct option. ठीक है, तो वो गलत नहीं हो सकता, इसलिए कंपाइलेशन फेल के चांसेस जो मुझे नहीं लगते यहाँ पे कुछ है। बाकी जो तीन ऑप्शन है उस पर ध्यान दो आप।
सर बी।
एग्जीक्यूशन रिजल्ट इन रन टाइम एरर, क्यों? जस्टिफिकेशन बताओ मुझे, ऐसा क्यों लग रहा है आपको?
सर बिकॉज तो ये है ना स्कैनफ पीआई का पॉइंटर का, तो
हाँ
सर
हाँ
उसकी वैल्यूज हम डालने वाले हैं,
बिल्कुल।
उसकी
यूजर
वैल्यूज
से, हाँ हाँ।
तो हम डालने वाले हैं, तो फिर सर हमको मालूम नहीं है सर।
देखो बेटा, उसमें क्या है कि आप वैल्यूज यूजर से लोगे ना आप इनपुट में, बराबर है?
यस
तो
सर।
वो वैल्यूज लिया आपने यूजर से, तो
यस
वैल्यू कुछ भी हो सकता है, वो कह नहीं सकते कि वैल्यूज क्या है।
यस
ठीक
सर।
है, अब वो वैल्यू कहीं ना कहीं तो स्टोर करना है आपको।
यस सर।
ठीक है, तो अगर मान लो कि आपको आई में स्टोर करना है, तो आप क्या करोगे, आई का एड्रेस दोगे ना वहाँ पे।
यस सर।
तो आई का एड्रेस तो ऑलरेडी पीआई के पास में है,
हाँ।
तो वही लिखा है आपने स्कैनर में, तो गलत क्या है उसमें? बराबर है ना?
यस सर।
PI is holding the address of I and you have written PI in place of address of I, तो वो तो बराबर है ना, वो गलत थोड़ी है। तो
यस
बेटा
सर।
जो भी आप इनपुट लेंगे वो कहाँ जाएगा, वो आई में ही स्टोर होगा, इतना समझ लो आप।
ओके सर।
तो व्हाट विल बी द करेक्ट रिजल्ट? आराम से सोचो, बिल्कुल घाई नहीं करना, टेक योर टाइम और थिंक करके बताओ मुझे कि अभी जो तीन ऑप्शन आखिरी के हैं उसमें से कौन सा सही ऑप्शन हो सकता है। पहले तो आप ये सोचो कि अगर आपको लगता है कि इस प्रोग्राम में एरर है, किसी भी टाइप का एरर है, तो क्यों है? तो मुझे तो कहीं कुछ एरर जैसा दिख नहीं रहा है। अब मेन में आप बोल सकते हो कि वॉइड नहीं लिखा है, इंट नहीं लिखा है, तो वो सब चलता है, वो एरर में नहीं काउंट होता है। ठीक है, आप मेन कोड पे ध्यान दो। ठीक है, जो अंदर लिखा है कोड उस पे ध्यान दो कि उसमें कुछ लग रहा है कि गलत है लिखा हुआ। अगर उसमें कुछ गलत है तो एरर हो सकता है वहाँ पे। ठीक है, अगर उसमें कुछ भी गलत नहीं है तो पहले दो ऑप्शन जो है वो तो रूल्ड आउट ऐसे ही हो जाएंगे आपके। ठीक है, तो फिर आखिरी के दो ऑप्शन बचते हैं आपके पास, उस पर फोकस करो और देखो कि दोनों में से कौन सा सही लग रहा है।
सर डी, क्योंकि हम ई आई की वैल्यू को इंक्रीमेंट कर रहे हैं और इसी को प्रिंट करवा रहे
दूसरे मेंबर को क्या लगता है, क्या ऑप्शन है?
हैं। डी डी।
डी ही लग रहा है, सभी को, दोनों को डी लग रहा है। ठीक है, चलो
करण।
देखते हैं तो। कुछ कहना चाहते हैं करण, बोलिए, नहीं तो हम इसको सोल्यूशन देखेंगे फिर।
नो सर।
ठीक है, तो आपको इतना कंफ्यूज होने की जरूरत नहीं है, बहुत ही सिंपल प्रोग्राम था, इसमें कोई एरर नहीं है। ठीक है, ये प्रोग्राम एब्सोल्युटली करेक्ट है और सही आंसर डी ही है। मैं दिखाता हूँ क्यों। ठीक है, तो यहाँ पे अगर आप एक ही चीज़ समझेंगे ध्यान से, तो पहले तो मैंने बता दिया आपको कि पी आई इज पॉइंटिंग टू द वैलिड लोकेशन बिकॉज पी आई इज होल्डिंग द एड्रेस ऑफ आई, तो स्कैनएफ में कोई प्रॉब्लम नहीं है। ठीक है। दूसरा चीज़ है कि प्रोग्राम एग्जीक्यूट होगा वो सक्सेसफुली, क्योंकि उसमें कोई एरर नहीं है। ठीक है, डेटा जो भी है वो कहाँ जाएगा, जो भी डेटा आप इनपुट में लोगे वो कहाँ स्टोर होगा, वो आपके पीआई में ही स्टोर होगा। सॉरी, पीआई के थ्रू कहाँ पे स्टोर होगा, आई में स्टोर होगा वो, बिकॉज पीआई इज होल्डिंग द एड्रेस ऑफ आई। ठीक है, तो डेटा आई में स्टोर हो गया और आपने फिर प्रिंट किया I+5, तो ऑब्वियस सी बात है कि जो भी आप इनपुट करोगे डेटा उससे 5 ज़्यादा वो प्रिंट होगा, है ना। तो लास्ट ऑप्शन है ऑन एग्जीक्यूशन द वैल्यू प्रिंटेड इज 5 मोर देन द इंटीजर वैल्यू इंटर्ड। ठीक है, ये सही है। तीसरा ऑप्शन सी है, वो क्यों नहीं है वो समझाता हूँ मैं आपको। क्या लिखा है उसमें, ऑन एग्जीक्यूशन द वैल्यू प्रिंटेड इज 5 मोर देन द एड्रेस ऑफ वेरिएबल आई। ठीक है, अब वहाँ पे एड्रेस पे वो क्यों नहीं जा रहा है, क्योंकि सोचने की बात है, स्कैनर फंक्शन को हमेशा एड्रेस लगता है और जो कुछ भी वो डेटा स्टोर करेगा वो आई में जाएगा। ठीक है, और आप प्रिंट किसको कर रहे हो, आई को कर रहे हो। आपने पीआई को प्रिंट किया है क्या, नहीं किया है। आपने आई में +5 किया है, पीआई में +5 नहीं किया है। अगर पीआई में +5 किया होता तो उस केस में आपका सी ऑप्शन सही होता, बिकॉज पीआई इज होल्डिंग द एड्रेस। ठीक है, लेकिन आपने आई में +5 किया है, तो ऑब्वियस सी बात है कि आई वो सिंपल वेरिएबल है ना, तो उसको वैल्यू अफेक्ट होगी उसकी, उसका एड्रेस अफेक्ट नहीं होगा। गेटिंग माई पॉइंट। तो तीसरा ऑप्शन रूल्ड आउट हो जाता है इसकी वजह से। ठीक है, तो करेक्ट ऑप्शन क्या है आपका, डी है ये। समझ में आया क्या, आगे बढ़ूँ मैं।
यस सर।
ओके ठीक है, नेक्स्ट क्वेश्चन देता हूँ मैं आपको। ठीक है, आराम से टाइम लगाना, एक एक ऑप्शन के बारे में अच्छे सोचना, फिर डिसीजन लेना। पहले तो पूरा प्रोग्राम ऑब्जर्व करना आपने कि कहीं कुछ प्रॉब्लम तो नहीं है, उसके बाद आप ऑप्शंस पे ध्यान देना। ये थोड़ा सा आपको ट्रिकी लग रहा होगा। ठीक है, देखो इसको अच्छे से और अच्छे से सोचो, बिकॉज इसमें ऑप्शंस काफ़ी है। ठीक है,
सर
हाँ जी बोलिए।
डी लग रहे थे, डी।
बी सेकेंड थर्ड एंड फोर ओनली।
नो सर,
सेकेंड
डी डी डी, फॉर ओनली।
फोर ओनली।
यस सर।
बाकी सभी में एरर आएगा क्या?
यस सर।
क्यों बेटा एरर क्यों आएगा? पहले
सर
इसमें क्यों एरर आएगा बताओ।
सर वो पॉइंटर वैल्यू तो खुद ही लेता है ना सिस्टम, हमको प्रोवाइड करने की जरूरत नहीं है ना सर।
बट अपन प्रोवाइड भी कर सकते हैं, जैसे मान लो कि अगर कोई पॉइंटर वेरिएबल है और उसमें आपको एड्रेस स्टोर करना है तो आप नहीं कर सकते हो क्या?
तो कह सकते थे, लेकिन डिक्लेरेशन गलत है ना।
डिक्लेरेशन में क्या गलत है बेटा?
सर ए
इंट
टू,
पॉइंट।
सर ए
बोलो।
टू, सर ऐसे लिखा हुआ ए टू। सर तो इसमें पॉइंटर कैसे दिख रहा है, ओ एड्रेस कैसे पॉइंटर कैसे
नहीं
डिक्लेयर हो?
नहीं, आप क्वेश्चन नहीं समझे। आप क्वेश्चन में क्या लिखा है देखो, विच विल नॉट गिव कंपाइल टाइम एरर इफ यूज एज अ लेफ्ट हैंड साइड ऑफ द असाइनमेंट स्टेटमेंट। ठीक है, तो आपको ये मान के चलना है कि वो जो ऑप्शंस दिए हैं ना, वो इक्वल टू के लेफ्ट हैंड साइड में लिखना है आपको। तो
ओके।
ऐसा कौन सा ऑप्शन है जो आप लिखेंगे तो एरर नहीं आएगा? क्वेश्चन ठीक से पढ़ो, है ना। वो डिक्लेरेशन नहीं दिया हुआ है, वो है कि उसमें अगर आप असाइनमेंट करते हो कोई वैल्यू, तो उसमें से कोई ऑप्शन ऐसा है क्या जो कंपाइलेशन एरर दे सकता है आपको। उसको फोकस करना है, कौन सा नहीं देगा कौन सा देगा वो पहचानना है आपको।
ओके सर।
करो आराम से करो।
सर ए लग गया है।
ए
यस सर। सर क्योंकि
वन
ना,
टू।
हाँ सर
बोलिए।
क्योंकि सी वाला बी है ना, वो मल्टी डायमेंशनल है, लेकिन इसमें सिर्फ
हम्म
सिंगल डायमेंशन दिया हुआ है।
हम्म हम्म
C
हम्म
में,
हम्म,
तो इसलिए।
हम्म। चलिए, सेकंड पर्सन जो है उनको क्या लग रहा है?
मुझे भी ये लग रहा है सर।
चलो मैं आपको इन्फॉर्मेशन के लिए बता दूं कि 2D एरे में भी आप सिंगल डायमेंशन देके एलिमेंट असाइन कर सकते हो, तो वो गलत नहीं है सी ऑप्शन। ठीक है।
सर लेकिन 2D एरे में सिंगल एलिमेंट देने से कैसे असाइन होगा?
मैं समझाता हूँ आपको। अगर आपने कोई स्ट्रिंग असाइन किया, ठीक है, जैसे मान लो मैंने लिख दिया राजू, ठीक है, तो उसको अगर 2D एरे में डालना है और मुझे मालूम है कि पहले रो में डालना है उसको, ठीक है, रो नंबर 1 में डालना है, तो कॉलम नंबर अगर मैं मेंशन नहीं भी करता हूँ, डायरेक्टली राजू उसमें असाइन करता हूँ तो ले लेता है वो। ठीक है, फिर वो कॉलम कैसे डिसाइड करेगा? बेस्ड ऑन दी कंटेंट्स इनसाइड द स्ट्रिंग। ठीक है, आर को पहले कॉलम में डालेगा, ए को दूसरे कॉलम में, ये बाय डिफॉल्ट होता है। तो स्पेशली स्ट्रिंग में ये पॉसिबल है कि आप दोनों इंडेक्स ना देते हुए भी आप एलिमेंट्स को डाल सकते हो।
सर
ठीक
लेकिन
है,
यहाँ पे तो इंट है ना।
हाँ मैं आपको बता रहा हूँ, तो वो इंटीजर में भी पॉसिबल है, मैं वही बोल रहा हूँ। ठीक है, स्पेशली मैं स्ट्रिंग का एग्जांपल इसलिए दे रहा हूँ ताकि समझ में आपको आए, बट वो सी लैंग्वेज में पॉसिबल है कि आप दोनों इंडेक्स ना दो तो भी वो एलिमेंट लेते हैं। आप थोड़ा सा एक्सप्लोर करना, उसको समझ में आएंगे आपको। ठीक है, इसमें एक ही जो आपका जो ऑप्शन है ए और बी, अगर आप देखेंगे ध्यान से तो वो दोनों सिमिलर है, उसमें कोई प्रॉब्लम नहीं है। ठीक है, ऑप्शन सी में भी कोई प्रॉब्लम नहीं है। सॉरी, एक मिनट, जस्ट जस्ट अ सेकेंड, लेट मी सी द करेक्ट आंसर फर्स्ट, देन विल डिस्कस अबाउट इट। हाँ सॉरी, पहला आंसर सही था आपका। दूसरे में हाँ सॉरी, तो मैं जो बता रहा था आपको, आपने सही बोला कि वो इंटीजर है। स्ट्रिंग में वो पॉसिबल होगा, ये शायद इंटीजर में पॉसिबल नहीं है, एंड दैट्स वाई वो थर्ड ऑप्शन जो है आपका वो गलत ऑप्शन है वहाँ पे, और इसलिए पहला है। ठीक है, आपका आंसर सही था, वो कॉलम वैल्यू इंडेक्स मिसिंग है उसका। ठीक है, तीसरा क्वेश्चन अगला क्वेश्चन देखते हैं, ये क्वेश्चन है अगला। जो सेकंड लाइन है इसमें जो दिख रहा है आपको, एरे डिक्लेयर किया है, उसके बाद में जो आई पी इक्वल टू ए आर आर प्लस 4 लिखा है, ये अगर आपको समझ गया तो आपको ये समझ में आ जाएगा कि क्या आउटपुट आएगा इसका। इसमें कोई ऑप्शन नहीं दिया है, तो आपको आउटपुट डिटरमाइन करना है। ठीक है, तो सारा लॉजिक उसी के अराउंड में है, जो आईपी का कैलकुलेशन है उसके अराउंड में है। और ये मैंने आज ही पढ़ाया आपको कि एडिशन ऑपरेशन कैसे करते हैं, है ना। तो वो अगर आपको समझ में आ गया तो यू कैन इजीली सॉल्व दिस। आपको ऑप्शन चाहिए क्या इसमें? ऑप्शन चाहिए होगा तो मैं दे देता हूँ आपको।
2 लग रहा है, 2।
2 लग रहा है आपको, ठीक है। और
प्रणय बोल।
सर 5 लग रहा है मेरे को।
5? प्रणय आप क्लोज है, थोड़ा ट्राई करो। आपका लॉजिक जो है ना वो सही जा रहा है। 2 नहीं है आंसर, मैं बता देता हूँ आपको, और 5 भी नहीं है, लेकिन क्लोज है आप।
सर 4 होगा।
नहीं नहीं नहीं, ऐसे करेंगे तो पूरा नंबर बोल देंगे आप फिर तो। कारण बताओ मुझे, 4 क्यों लग रहा है आपको?
सर वो पॉइंटर थे +4, 1 2 3 एंड 4।
ठीक है।
सर सही है क्या?
नहीं नहीं, बताता हूँ मैं सही आंसर क्या। सही आंसर है उसका 6। ठीक है, अब मैं कारण के साथ में बताता हूँ 6 कैसे आया हो, ध्यान दो। ठीक है, सबसे पहले ये सोचो कि ए आर आर जो एरे नेम है, ठीक है, उसका बेस एड्रेस क्या होगा? उसका बेस एड्रेस होगा
0 0।
एड्रेस ऑफ फर्स्ट एलिमेंट, बराबर है।
हम्म,
ठीक है, तो आपने लिखा है इक्वेशन आई पी इक्वल टू ए आर आर प्लस 4, बराबर है। ठीक है, अब ए आर आर जो वैल्यू है, ए आर आर किसको इंडिकेट करता है? वो इंडिकेट करता है बेस एड्रेस ऑफ द एरे, बराबर है। एरे नेम इटसेल्फ इंडिकेट द बेस एड्रेस ऑफ द एरे, ये हमने पढ़ा हुआ है सबने। अब बेस एड्रेस क्या है? ए आर आर 0, उसका जो एड्रेस रहेगा वही बेस एड्रेस है। उसमें आपने 4 ऐड किया, तो ए आर आर 0 किसको फोकस कर रहा था? किस एलिमेंट को? पहले एलिमेंट को, 1 को। उसमें आपने 4 ऐड किया, इसका मतलब क्या हुआ? 4 एलिमेंट से आगे की तरफ जाएगा वो एड्रेस उसका, मतलब वो नेक्स्ट 4th एलिमेंट के पास में जाएगा। तो नेक्स्ट एलिमेंट कौन सा है? 2। एक से आगे जाने के बाद फिर उससे आगे गए तो 3, फिर उससे आगे गए तो 4, उससे आगे गए तो 5, बराबर है। तो अभी आईपी किस पे पॉइंट कर रहा है? किस वैल्यू पे? 5 पे पॉइंट करेगा अगर आपने उसको प्रिंट किया यूजिंग पॉइंटर। तो इतना बराबर है? यस और नो?
हाँ
समझ में आ रहा है ना मैं क्या बोल रहा हूँ? आपने एड्रेस को 4 से आगे बढ़ाया, इसका मतलब क्या है, 4 एलिमेंट से आगे जाएगा वो। तो इनिशियली वो कहाँ था, पहले एलिमेंट पे था, क्योंकि बेस एड्रेस दिया आपने उसमें। ठीक है, तो पहले एलिमेंट 1 पे था, आपने 4 ऐड किया तो 4 से आगे की तरफ जाएगा वो। तो वो कहाँ चला गया, 5 पे चला गया, बराबर है। आईपी अगर आप प्रिंट करते हो प्लेन आईपी, सिंपल आईपी, तो वो किस पे पॉइंट कर रहा है, वो पॉइंट कर रहा है 5 पे। और सिंपल आईपी का मतलब ही क्या होता है, बेस एड्रेस ऑफ आईपी। समझ में आ रहा है, बेस एड्रेस ऑफ आईपी। नाउ अब आपने लिखा हुआ है आईपी ऑफ 1, इसका मतलब क्या है कि बेस एड्रेस ऑफ आईपी से एक आगे जाना है आपको। ठीक है, कहाँ जाना है, बेस एड्रेस ऑफ आईपी से एक और आगे जाना है आपको। तो बेस एड्रेस ऑफ आईपी कहाँ पॉइंट कर रहा है, 5 को पॉइंट कर रहा था, एक और आगे जाएंगे तो कहाँ जाएंगे, 6 पे जाएंगे, इसलिए उसका आंसर आएगा 6। समझ में आया क्या,
यस सर।
समझ में आया क्या?
यस सर।
हाँ, चलो ठीक है, नेक्स्ट प्रोग्राम देखते हैं। ये नेक्स्ट प्रोग्राम है, इसमें भी ऑप्शन नहीं है। ठीक है, आपको इसको सॉल्व करना है और ये बहुत ही मज़ेदार है, मैं आपको बता दूँ, बहुत ही इंटरेस्टिंग है ये। इसको टाइम लगेगा सॉल्व करने में। तो जो सारा कुछ खेल है वो है आपके इस इक्वेशन पे, सम इक्वल टू सम प्लस पॉइंटर बी माइनस आई माइनस पॉइंटर ऑफ बी माइनस आई। ये अगर आपको समझ गया तो आप सॉल्व कर लोगे इसको। इसमें टाइम लगेगा क्योंकि आपको लूप चला के देखना पड़ेगा, एक्सिक्यूट करके देखना पड़ेगा। तो पेशेंसफुली आराम आराम से उसको करो और टाइम लो और मुझे सही आंसर बताओ।